welcome to today's video. Today we are going to do an RGB LED project. You can also access this project from the Arduino zip file which I showed you in the previous video. So you just go in the folder, then you go to downloads or anywhere where you had the zip file before. Click on this, then click on the language of your choice, and then click on the LEGO starter kit. So you already get this PDF, and then you can access the lesson for RGB LED project. But I'm going to go into much more detail so you can listen to me also. So for this project, the components which will be required is a LEGO Uno R3 board, a breadboard, 3 resistors, an RGB LED, and 4 male-to-male jumper wires and a USB cable. Our main aim of this project is for the LED to light up first as red, then transition into green, then to blue, and then back to red. So that's our main aim of the project. Let's see if we can achieve this. So before we get started right on this project, I want to talk a bit more about what an RGB LED is. So an RGB LED has 4 pins. One has a blue LED, one has a green, and one has a red. So and one is the cathode. So RGB stands for red, green, and blue, and there's red, green, and blue LEDs built in inside the main RGB LED. And as the blue, green, and red LEDs are connected to digital PWM pins, you can actually control the brightness of each LED, essentially getting any color you want. And for the cathode, the cathode will be connected to the GND to essentially complete the circuit. So yeah, that's essentially what an RGB LED is, and that's going to be the main component of our project. Y'all must be wondering what a PWM is. I'm going to cover that in more detail when I'm explaining my code, but for now just keep in mind that inside the RGB you can control the amount of blue, green, and red using the PWM. Now before I explain to you all the connections in my circuit which I've made, I want you to take a look at the circuit layout. This is the overall circuit layout. These curly lines over here, these represent resistors. These are 220 ohm resistors, and over here you can see the letters RGB. They represent the red LED, green, and blue LED respectively. And see, these are the overall connections. So this will help you a little bit more, so you can take a look at it. So now I'm going to show you how to do the connections of the whole circuit and the schematics. So first, this is a 4 LED folded RGB LED. So in this, notice the LEDs carefully. The longest LED is the cathode. It's called the cathode, which gets connected to the GND, and the other 3 ones are the built-in LEDs. So how I'm going to connect this is I'm going to put these LEDs in the main grid, in the back row of one of the main grids. Suppose I put it in this main grid. So you need to push it a little bit so that it goes completely in. And whenever you're connecting LEDs, as I said before, always put the resistor. So this is a 220 ohm resistor which I'm going to put. So make sure that it's in line with make sure it's in line with the LED you're connecting it to. So I put the resistor. Now this is the blue LED which I'm connecting first. So for blue, I'm going to put it in digital PWM 3. So I'm using a blue male to male jumper wire, as you can see, so that it's easier for you to identify. So I'm going to put it here. So if you look at the LEGO Uno R3 board carefully, you're going to see it's written digital PWM here. So inside digital PWM pins, you're going to see all these numbers over here. So I connected it to 3. Now for the second one, we are going to connect the green. So we are going to first do the cathode. Cathode is the longest one, which is the second LED. So for this, I'm going to connect it over here. I'm going to talk about breadboards also a little more. Breadboards allow you to make prototype circuits. So I'm connecting the cathode to the GND. GND stands for ground, which is used to essentially complete the circuit. Now I connected the blue, I connected the cathode. Now I'm going to connect the green. So actually wait, sorry, I had to do it in the second one. I did it in the third accidentally, my bad. Now I'm going to do the green one. I'm using a green wire again. Okay, I put the green, and I'm putting the green on digital PWM 5. So look at the numbers very carefully here, because you're going to have to, in your code, you're going to have to state the numbers so that communication can take place. Now finally for the red one, I'm going to put this on the last one. Okay, connected, and I'm going to put this on 6, digital PWM 6. Okay, one mistake, I forgot to add the resistors, my bad, I'm sorry. Okay, now I'm gonna add the resistors. So you have to add the resistors very carefully because it's a little loose, so you need to make sure to add it carefully. And resistors don't have a positive and negative side, so you can like put it either way around. And also in the breadboard, you see these main grids over here with four holes in each row and huge columns. So basically when you under these holes there are metal strings which provide electricity to transfer, which provide a way for electricity to transfer and make connections. So whenever you put something here, so whenever I put a wire here, and suppose I put a wire here, then that connection will remain throughout these four holes where I put it. So suppose the resistor is connected to this hole over here and goes to this whole row will be controlled by the resistor, will be the charge of that resistor basically. And these shorter rows with two rows and huge columns, if I have a wire connected here and it's positive, then this whole column will become positive. So this is how a breadboard works. Used to prototype circuits, it's very easy, but breadboard you have to make sure that the connections are secure, because sometimes it's not, and that's a concern. So overall, yes, this is my whole circuit connection. This is the final schematic. Take a look at it carefully. I also shared the circuit layout previously, so you can look at that also. So now let me explain to you guys my code. So in lines 2, 3 and 4, as you can see, I'm defining each of the pins to which my respective LEDs are connected. So suppose the blue LED is connected to digital PWM3, respectively the same for green and red. And then under the void setup, I'm writing code which is basically setting up everything, like code which gets run once only. And lines 8, 9 and 10 use the pin mode function. The pin mode function takes two arguments, the pin number and the mode you want it to be in. So it's written red here, but you might be wondering red is not a number, but actually this is representing the digital PWM6 over here. So I have done the same for all. I've defined variables pins over here, and I'm using that in the pin mode function. So in line 8, suppose it's saying pin mode red and output. Red means pin number 6, and we want it to be in output mode, means we want our pin to receive instructions which we are writing. And the same is for lines 9 and 10. And then 11, 12 and 13 is essentially I'm writing code which I also want to be run once using the digital write function. The digital write function decides whether to send voltage or not. So we can decide whether to send voltage or not by using high or low. High means you're sending voltage, low means you're not. So in line 11, it's saying digital write red high. This means that you want to send voltage to digital pin 6 where the red LED is connected. This will make the red LED glow, and the green and blue is low, means no voltage is passing through, meaning only the red LED will be on, and at first the RGB LED will turn red. Now before I explain the code under my main loop, I want to explain to you all what PWM exactly is. So PWM stands for Pulse Width Modulation. So it's basically a technique where you can control how much voltage goes to the digital pin to which the LED is connected to, and using that you can control the brightness of each brightness and frequency of each of the LEDs which is there inside the RGB LED. So basically, the PWM, the length of one pulse in a PWM is dependent on the Arduino hardware. So in this case, it's 1/500th of a second. So and in the analog, and I can communicate different values of voltages, and I can use the PWM using the analog write function. So in the analog write function, it takes two values. One is the analog pin which I want to send the voltage to, and the other one is the voltage value which is anywhere between 0 to 255. So suppose if I choose 127.5 in the value, what will happen is for half of 1/500th of a second, which is for 1/1000th of a second, the digital signal will be on, meaning the LED which I'm sending it to will be on, and for half the time it won't be on. So by changing the values, I can control for how much time the LED will be on compared to the whole duration of the pulse. So that is basically what PWM means, pulse width modulation. It's really interesting, and we can communicate, we can use PWM by the analog write function. Another important detail I would like to include about PWM is that when you pass values, voltage values in the analog write-up function, what you're actually doing is you're changing the proportion of the time the digital signal is on to that of the whole pulse. This is called the duty cycle. Now to move on, I have in line 17, 18 and 19, I have created three integer variables, red value, green value and blue value respectively. And I'm going to use these variables in my void loop, which is basically a code which I write under the void loop is the main code which gets executed over and over again in a loop, and like it's the main execution gets done under the void loop. And inside the void loop in line 24, as you can see, I am also creating another variable, delay time equals to 10. This basically means this is basically a variable which equals to 10 also. And over here I am changing the red value variable to 255, and green value and blue value still remain 0 and 0. And I've written this is unnecessary because you've already turned on red in the setup or in the previous loop, so this is not necessary, but just for clarification. And then we come to our main code over here, which is the for loop. Over here we are creating another integer, I equals to 0, and then we are saying if I is less than 255, keep incrementing I by 1. And then we are saying, and then as long as this loop keeps going on, we are decrementing red value by 1. So from 255 to 254 to through 253, it'll keep going on like that till the loop finishes. Whereas the green value will go from 0, 1, 2, 3 as long as the loop keeps going on. So by the time this loop finishes, we will have the red value becoming 0 and the green value becoming 250. And under this loop we are also doing analog write function, which is basically controlling the amount of voltage and basically controls the duty cycle, which is a concept inside PWM which I'm going to explain in more detail later on about analog write-up function and PWM. But for now, just understand that analog write-up takes two arguments, the pin number, and which is represented by red in this case, which is 6, and the voltage which you want to pass, which is the value between 0 to 255. And inside this loop, this value keeps getting passed on until this value finishes. And as you can see, and when this loop keeps getting carried on, the red value keeps getting decreased and the green value keeps increasing. So as this loop goes on, you will see more of green and less of red. And yeah, this is it. This is just explained this loop. And what I'm essentially saying is after each time the loop gets executed, delay by 10 seconds. So delay by 10 seconds so that it doesn't, you can see the change in the colors. So delay time is 10 microseconds, 10 milliseconds. So you can see the change in colors. Now let's go to our other part of the code. After we completed this first main loop in our code, in which basically what happens is a transition of color happens. So from red, the LED goes from green, so red to green. Now the LED is currently fully green after the first main loop. So now what our goal is to fade this green color out and bring blue in. So let's see how we'll do this. So it's basically the same concept, just different it's basically the same concept, just different variables and stuff. So in this loop, what happens is I is equal to 0 again, and as long as 255 is more than I, increment I by 1, and then green value. As this loop keeps happening, the loop will happen 255 times until I is equal to 255 and the loop stops. So until then, the green value, which is equal to 255, it keeps decrementing by 1, whereas the blue value keeps increasing. And while all this is happening, we are telling them to pass the real-time voltages to pin of green, and the value is green value, which keeps decrementing. And whereas for blue, we are passing the voltages of the blue value to the blue LED pin. So as you can see, as this will keep happening, you will notice that green keeps decreasing and blue will keep increasing, and by the time this loop ends, it will be fully blue and 0% green. And once this happens, and after each iteration of the loop, we are again dealing it by 10. And in the loop below also, it's the same concept again, except that we are fading out blue and bringing out red when I equals to 255. And you see these double slashes over here, that just means that whatever I write in front of it gets commented, so it won't actually be executed. So I hope this is clear. This is the code I've written, and I'm going to test it out. So let's see if it works. So I'm now trying the code. So I'm now connecting my USB cable, and there'll be a confirmation signal which will show in your Arduino board, and then you choose the correct board. Then you check if you have chosen the correct port and everything. So yeah, COM5 port, that's for me is the correct port. Then you first verify the code to see if there are any errors, and then you upload it. So you can see a confirmation message here saying done uploading. That means it's done. So now I'm going to show you if it works or not. So this is my RGB LED here. It's keeping on changing its colors. It's changing very fast, so the frequency is changing very fast, so it looks so therefore, as the frequency is changing very fast and the colors are fading, it looks like the brightness is changed, but it's actually just an optical illusion. It's actually just the duty cycle which is being changed. So yeah, it's working the whole cycle. It's turning red, then green, then it's fading, it's turning blue, it's blinking. So yeah, it's working. Congratulations guys, you just completed a RGB LED Arduino project. Congrats.